Hello everyone. Welcome to the first lecture in this course of compiler design. And in this particular class, we are going to look at language processors. Now we already know that a high-level language is a language in which we write our code or our programs. Now in order to execute this program, we need it to be converted into the language that the machine understands, which is the machine language. So the process from writing a program in a high-level language till its execution goes through a number of softwares known as language processors. So let us look at these language processors today. So there are different tools which are associated with the process of converting a program written in a high-level language till it is executed by the machine. And some of these are your compilers, translators, preprocessors, interpreters, assemblers, and many more. So let us look at these. So the most generic of all such language processors is a translator. So a translator does is that it takes in a source language program and it converts it into a target language program. So the basic work is translation from one language to another language. And because, as I said, it is generic, so the source language can be any language. It can be a high-level language, it can be a machine language, it can be assembly language, anything. And the target language also can be anything. It can be a high-level language, assembly, or even machine language. So this is the most generic form of it. Let us move to something more specific. So a compiler. So a compiler is nothing but a translator, but now the input to the compiler is always a high-level language. So the source language or the source language program is always a high-level language program. So the compiler, what it does is that it converts from this high-level source language program to a program in another language, that is the target language. And again, here we are not giving any specifics as to what would be the target language. So it can be an assembly language, it can be a machine language, and so on. So compiler translates from high-level language to some target language. And while performing these translations, if there is any error in the program, not because of how you have written it, but because of errors in the language, okay, you have not written the program according to the language, then it will detect the errors in the process. The next language processor we're going to talk about is the interpreter. Now, unlike the compiler, which converts a high-level language program into a target language program, the interpreter also does something similar, but it does not convert the program into another program. Instead, what it does is that it takes one line of code of the source program, converts it into machine language. Okay, now you can note target source is a high-level language, target is a language is machine language. So it takes one line at a time, converts it into machine language, and then executes it. So compiler does not do any execution, but the interpreter does the conversion as well as the execution. So after that, it again takes the next line of code in high-level language, converts it into machine language, and then executes it. And so on till the whole program executes. Or there are errors in the program, then the interpreter will give out whatever is the error and stop. Now because it does this one line at a time, so it is definitely way slower than that of a compiler. But there are advantages also. Now if when you work on Java, you will find that Java uses an interpreter, and there are the Java interpreter performs has got many optimizations inbuilt into it, so which makes it comparatively faster. So that is an interpreter. Then we have again another translator. which is we call the assembler. So now what does the assembler do? It converts or translates from high level language to assembly language. So the source language is high level and target language is assembly. Then we have the preprocessors. Now I'm sure you must have written C programs where you have used header files or other external files, okay, and you must have also written macros. So the preprocessor, this is not a translator. It is just a language processor. So what it does, it takes as input your C program or a high level language program, and it combines the code that is there in the multiple files. So the code which is there in your header files, so if there is a definition for printf in your header file, it will bring that function printf from the header file and include it in your program. Similarly, if you have written macros in your program, then the macro expansions will be done by the preprocessor. So the preprocessor takes as input a high level language program, and output is still the same high level language program, but it has been expanded. Expanded why? Because of the expansion of macros or because of combining of multiple files that were referenced in the original file. So that is the preprocessor for you. Next, now that we have seen these different language processors, let us look at the program execution steps. What happens from the time you write a program till you execute it? So we start off with the programmer, that is you, who types in the program in a high level language. So you can use an IDE like you have been using for C or say .NET, VB.NET, or any programming language that you have used. Or it may even be just a simple editor like Notepad, when you can write your Java programs using a Notepad editor. So this is the IDE or the editor. So what you get, the output from this is a high level language program, okay. Then this is given to the compiler. Now what the compiler does here is that it takes as input a high level language program, and the output that it gives is a target language. So here we assume that it will give you an output which is an assembly language program. Now why assembly language program? Because it is easier to have a assembly language program as compared to your machine language program. So it converts from high level language to an assembly language program. But this is not always true, because you may have a compiler which can translate directly into machine language. But in general, most of the programming languages that we use, it uses a compiler, always converts from a high level language program to an assembly language program. Now this assembly language program is given to an assembler, who then converts it into a machine language program. So you have the machine language program. So your source program, high level language program, has been converted into assembly language program. From there it has been converted into machine language program. Now comes in the linker. Now the linker, what it does is that it links your the definitions, the relocatable codes, all these are linked by the linker. And then when when all these are linked together, you have the resolved machine code. Okay, so the resolved machine language program, which is then used by the loader for executing. So finally the output of the loader is your executable machine code. So these executable machine code, now you can execute it on any program, on any machine on the machine that for which it has been converted. And then if there is no error, the program is executed. If there is an error, then you have a debugger which will tell you that these are the errors. And then the programmer will again go back to the IDE drawing board again and then start correcting those errors. And then after that you follow the same pattern, same process: compiler, assembler, linker, loader, and the process goes on till you get an error-free program. So these are the steps which are involved in the program execution. So in this course we are going to look into the different tasks that is performed by the compiler here. So we are going to assume that the compiler assembler part, this two is combined. So we will have a high level language input and the output would be your machine language program. So that is what we are going to learn in the next few lectures. Thank you.